Good morning everyone and welcome to my channel. Today we are here to see the third machining operation. So I already created a panel with a couple of geometries and the third one is of course the master. And we can start immediately to open the machining, the milling in this case. We start from the top and the first thing we see basically is that we need to select a geometry. So we can start with the master, so the perimeter. Then we have the tool radius correction. So it is you can select center, and let me use the top view so we can see better where this little arrow will be. So center, of course, is right in the center of the geometry. Left will be inside. Right, it is outside. And then since it is a closed geometry, we also have internal or external. Let me immediately explain what is the difference between left, right, internal and external. Of course, if we have an opened geometry, we can only select left, right or center. These will be the three options available for an open geometry. But in case of a closed, it's always better to use internal or external for one simple reason. Let's start with the right correction, so the tool outside the geometry. We can then select a tool from the library. Okay. And we can assign a depth. So we go by a number. We know that the panel in this case is 19.2 millimeters. So we can go 10 if we don't want to go through. Otherwise, remember that if you enable the through cut, so let's actually look at the panel from the side view, actually front. So if you leave a 0, the tool will be right on top of the panel. If you enable the through cut, basically your reference will become the bottom of the panel. So whatever you put here as a value will be from the bottom down. Okay. Let's go back to 0 or 1. Okay. And talking again about the correction, so we selected the right correction. It is the tool is outside, and going in this direction is basically a conventional cut, right? So if we see the simulation, it is a conventional cut. But look what is gonna happen. So I'm gonna open the machining again. If we decided to climb, right, for some reason, maybe with some material, you know, the finish will be better in one way, and with some other is the opposite. So it's up to you. You can choose, but look what happens if I reverse the travel direction. Now, my correction is wrong, so it is inside. And this is the simple reason why we prefer, for closed geometry, to select internal or external, because if you select that, so we go external, even if you change the travel direction, the tool correction will stay the same. With that being said, then the next thing is the starting point. So if you like to start from the corner, you are free to do that. Otherwise, you can move the starting point just using this function, leading point selection. So when you activate the function, you are able at this point to click anywhere around the geometry to determine the new starting point. You see the arrow now is there. I need to calculate, and my tool will be moved to that start position. we have seen already the depth, we talked about the depth, so then we will have lead in, lead out. So we have different types, and as I always say, I mean, bSolid has a graphic basically that helps a lot. So if you are not sure about what the specific lead in, lead out, or actually what the specific parameter will do, just try and see the graphic what is gonna do. So if you select the line, we see now there is a 90-degree angle. So let me confirm so we can see it better. From the top, we will see that the approach will be a 90-degree angle with a simple straight line. Otherwise, I mean, you can select an arc, and I know we can change it to 45. You see, again, 45-degree approach. Otherwise, I mean, there are a lot you can test, you know, and these are the 3D are the most used for especially nesting, the nesting applications. And then for the lead out, you can leave it as the same as lead in, or otherwise you can specify something different, or maybe turn it off. None, it's basically you don't want one. Or otherwise you can select and change the parameters of a different one. But for now, let's leave without. Then the next tab is a vertical step. So we want to go through, cut this panel all the way through in this case. And vertical pass is 1, so it will do the cut in one shot. If we want to split it, basically, we can split it. And in this case, if I do not enable any other parameter here, let's see what is going to happen. So simulation, play, it will start. And when it will get to the end point, it will go up to go back down and start with the second step. And that will be repeated also for the third and last. So if we want to avoid the up and down movement, so we need to activate also eliminate lead out. So we can enable that, calculate, play the simulation, and now we will see that when the tool will get to the start, which is also the end point, it will go down directly instead of going up to the next step. Then we have eventually the possibility to enable the bidirectional. And what that does, this is a function that is mainly used for saw cuts, where we don't want to chip the bottom of the panel. So we go one way, you know, halfway as a depth. And then once we are at the end of the cut, we go down, all the way down, and we come back in the opposite direction to avoid chipping the bottom of the panel. But in this case, also for milling, I mean, if you want to use it, is basically cutting in one direction for the first step, so it's conventional right now. And when it goes down to the next, it will change direction, so it will be climb. Okay. Stop, close. Again, the graphic and the simulations help a lot to see what you are playing with and what is going to be the result. So we can eventually specify the last step. So like, I don't know, if we want to leave an onion skin or something, we can say, okay, the last step, do 3 vertical passes, but the last step has to be 0.5 millimeters. So as you can see now it's changed. It will do basically everything in 2 steps, and the third one will be leaving only 0.5. Sorry, will be removing only 0.5 millimeter. Then last option here for the vertical passes is the incremental. So like the word says, basically when you select incremental, it will start from the top of the panel, and by the time it gets to the start, which is also in this case the endpoint, it will be at the depth of the first step. So same thing for the next. By the time it gets to the start point, it will be at the second step depth. And then it will be cleaning everything for the final. Stop. Then horizontal. So in case we want to, right now I have a 5 millimeter excess material all around the parts. So with the first pass, when I go around with my tool, I will be removing 5 millimeter in one shot. If that is not what I want to do, I can change the horizontal passes, but differently from the vertical. When you use horizontal passes, you also have to specify the step. So I don't know, I want 2 horizontal passes, and see, nothing happens because there is no step specified. So I want 2.5 millimeter. I want to remove 2.5 millimeter each step. Well, so in this case we have vertical and horizontal enabled at the same time, so it will do the same thing twice. Of course, the first time staying 2.5 millimeter away from the final geometry, and then the second time it will be cleaning up against the geometry. Just because we have both passes enabled, vertical and horizontal. Okay, so close. What next? We have seen vertical, horizontal, the speed. So normally it's gonna take the default of the tool. Otherwise, if you don't like the default of the tool because you are working with the different material, remember you can always turn the default parameters off and change them directly here on the machining. Of course, you are allowed to play between the minimum and maximum that was defined while creating the tool. Safety, same thing as the speed data. It takes the default, so directly from the tool. Otherwise, you are unable to turn the default off and change it, maybe because for a particular case you want to stay a little bit safer. Then machining data. So here we have different parameters, starting from the first one, Actually, let me go back and change. Let me bring back to 0 the vertical, actually to 1. Okay, horizontal 1. Okay, so we were saying machining data, so excess material. This is if we want to leave some excess material, maybe because this is a rough pass and we want to leave something for the finish, right? So I can stay away from the geometry 1 millimeter with this machining to go and, you know, come back with a different tool for the finishing. Then start Z and end Z. So this will be added to the depth, to the specified depth. So if we want to start maybe a millimeter down, let me see. You see that is my final depth selected from the previous fields. But if I want to increase that depth, I can do it directly from here, so a millimeter deeper. And the same thing is for the final. So if I want to go all around and end the cut even deeper than that, I can go and enable also that. So I will go like incremental, you know, start from 1 and will end at 2. So 0, 0, we go back to the original condition. Then percentage length, what this parameter does. So if you want to do only the 50% of the selected geometry, we can leave the percentage enabled and specify 50%. And as you can see, instead of going all the way around the geometry, it will go halfway. Otherwise, if we turn that off, the percentage off, we will go by a specific value. So, I don't know, I want to do only 500 millimeters of this geometry. Calculate. And so, that is what the software will do. Go back to 0. Then initial extension, so initially actually and final extension. So in case of a closed geometry like this one, initial extension is also used to move the starting point. So if I want to start, you know, change the starting point 100 millimeter, you see, I'm able to do it from here. Or I can go in the opposite direction using negative. And this is something I didn't say earlier. So the excess material, if you go positive, it goes far away from the selected geometry. Otherwise, if you want to remove more, so that 0 is the original condition. But if you want to remove more material, you are allowed to do that, just going negative. Okay, that was just a quick parenthesis. So going back to the initial extension, so positive or negative, it will move the starting point for closed geometry. Otherwise, it will extend the cut of about 100, or it will shorten the cut if you use it with the minus sign in front of about 100. Instead, final extension, for open geometries, it will extend the cut for whatever is specified. Let's use 100 also here. And in case of closed geometry, it will make an overlap of 100 or whatever, you know, is written in the field. Then deceleration distance when the geometry is not tangent, like in this case, we can increase the deceleration distance point if we want, and we can also specify the deceleration speed. Otherwise, we can leave it the default. And then let me actually confirm this geometry or turn it off and start with a new one. Because talking about milling, remember that if the same parameters, actually let me go 10 millimeter deep. If the same parameters are true also for another geometry, remember that you can apply the same machining to multiple geometries. Okay. But we were here in machining data, so in the next parameter it will be angle along the z-axis. AR is to change the rotation, so the rotating angle in case you have a z-axis on the machine. And the TCP tracking. So let's say we want to change the angle of this cut. We can assign an angle here. It is 45. But look, let's look at the simulation to see what it does. It will stay oriented in the same direction, just 45 degree with a 45 degree angle. So this is what I will get. Instead, if I want to do like a chamfer all around, of course this can be done with a 5-axis or a 4-axis machine with an aggregate with the proper orientation. You can enable also the TCP tracking. So it will follow the geometry, but with the specific angle, but also rotating the z-axis around. Then continuous machining, I mean, just to make a quick example of continuous machining, we can draw, or actually we can use this one. Let's explode this one. Instead of a polygon, if we explode it, we should get exactly 5 lines. So let's say that we want to select all the geometries here and apply a milling, right? What is going to happen? We select the tool and we can see the tool 5 times. Why? Because it will, well, I left also the circle on, but let me change the depth. And let me turn off the circle. So it will treat every single geometry as individual geometry. So it will do 5 different cuts. But let's say we want to join these together like it was before. We can go in machining data and use the continuous machining. So at this point we will get only one start and end point like it was before. Because this machining, this function is able to connect again the geometries even though they are separate. And you can also specify the distance. So if they are far apart, you can also say, okay, join everything within this range. And you can also specify the fillet radius just to make them tangent. And eventually, if instead the lines are overlapping, you can remove overlaps just selecting that one. Chip deflector quickly. You can select it, and the default usually is fine. You can play eventually with the distance if you have the chip deflector, because that it will basically change how close the deflector has to be with your profile. So by default is 5 mm away if everything is set properly, and eventually we can play with that. So with that being said, let's go in the advanced parameter. Here the main thing will be the hood. So if it is left at 0, it will automatically select a position based on the length of the tool, if it's a 3-axis or 4-axis machine. Otherwise, for the 5-axis machines, you will always have to specify a position for the dust hood. Otherwise, it will stay up. And here we can also select a specific spindle. So in case your machine is configured with 2 different spindles, you can force one of them using this field. And I guess this is it for the basic. Thank you for watching, and next time we will talk about the 3D engraving, which by the way is an additional module. See you next time.